So let's begin. Firstly, a warm welcome to the summit. Today, Bart and I shall speak about the benefits and our journey to building a homemade ML platform. So this relates directly to MLOps. And to start with, MLOps is machine learning operations. What does it mean? It's basically pipelines that help streamline machine learning workflows and also at the same time help you monitoring and creating a version history of everything you do in terms of machine learning. So let's begin with why do we need such a system in place, right? The first thing that we need to do is have efficient workflows and fast results. So data scientists and engineers often find themselves spending months on development and deployment of models. There is an evident need for a smoother process and efficient workflows in order to bridge the gap between scientists and engineers alike. Versioning and experiment tracking, often historical metrics and results of previous experiments are lost during the constant battle of the best model. Versioning helps us learn from our mistakes iteratively and brings about an environment where performance of past experiments can be compared in depth with current experiments. Automated model tuning. So tuning models is a tedious and time-consuming task, and most data scientists can back me up with this as well. Automating a lot of this would save up a huge amount of time and precious resources, allowing for real-time validation and even offline validation in a production environment. Accuracy and hyperparameter tuning does not always fare well in a simulated environment. Hence, we need to have some kind of real-time automated model tuning. The next one is simplified model management. As you create models on various Jupyter notebooks, it may become chaotic. Who created the model? What kind of features did you use? What kind of feature versions did you use? So there are plethora of models that can be created, but managing them becomes an absolute nightmare. What MLOps can provide is a one-stop shop solution to manage them in dire need of current times. Next is A/B testing. A/B testing is often overlooked as due to the fact that data scientists generally believe that, hey, accuracy and precision may cut it. It always doesn't work, but what you may try training in your simulated environment may look very different in a real-time environment. Hence, A/B testing when you roll out your model, and this also applies doing it in a staging environment and finally in a production environment. Evaluation of your model can always be done on a staging environment, but at the same time, it also ensures that this is how your model will behave in a real-time scenario. The next one is quick and consistent deployments. Generally, the need or when a machine learning model is deployed, there's always some special component required to support it, especially when you don't have an MLOps pipeline in place. Now, this takes a lot of time from creation to development. It may take anywhere to 6 months to 12 months. What an MLOps pipeline guarantees is much shorter timelines with an error-free process, approximately about 4x shorter. You can basically roll out models every second week and ensure that they are not going to cause any problems with your product. Go to the next slide, please, Bart. So what is Positron? So we basically thought about all these problems and what we face in the search team currently, dealing with billions and billions of data points that come in every day. We wanted to have something in place where it would make the life of data scientists much easier, data engineers and our backend engineers together. So Positron encompasses all these creators together, and this is what we envisioned of it. So Positron is defined or is Truecaller's in-house ML platform that the search team uses that bridges the gap between data scientists and engineers, providing a one-stop shop solution for training, testing, development of multiple machine learning models. It can take months and years to deploy a model and adopt company-wide processes. Our vision is to overcome these feats and create a smooth process that is understood without much effort. Having an MLOps solution in place does not always guarantee understandability. Our minimal and simple configuration-based design is the brains of Positron that provides inputs and parameters to every single component downstream in the pipeline. We also believe that reinventing the wheel is not always the best idea. There are plenty of state-of-the-art models out there that can be reused to solve various business problems. Building a system that can accommodate support for various model flavors is the primary goal of Positron. So serving different model flavors is something that we really wanted to do with Positron. So we had a lot of data scientists creating these Spark models, Python models, and R models. And we realized that they possibly may need different platforms to be deployed. This is when we basically went out and thought about, hey, what options do we have in terms of creating a one umbrella where we can deploy all of these models? And you'll see in the further slides as to what technologies we've used. So offline, sorry. So offline feature stores may garner good results where real-time information does not move the needle much. We realized this need was apparent at Truecaller. Hence, integrating support for online and offline feature stores was a great facet to have for us. Especially, you can see how well it performs in real-time feedback systems. So these were two components that we also believe was required in Positron's pipeline flow. Let's go to the next slide, please, Bart. So these are the various technologies we use. Yes, there are quite a few, but we wanted to make sure that we're creating something that all business units within the company can use and not only the search BU. And these are basically the various technologies that we went with. Scylla is our configuration-based tool. Google BigQuery is used for all our offline operations, data munging, and even our training processes. Our complete structure, our backend, everything at Truecaller is built using Scala. So we wanted to have that integration as well in terms of using this MLOps platform. Kubernetes is where we use our containers, is where we the services that use our containers. And Apache Spark is our main facet. Now, this was a big push for us as to, okay, we have so many Spark models at Truecaller, and how do we migrate these models without converting them to Python or R models later in the future? Apache Airflow does orchestration of your offline feature stores. At the same time, it also carries out small sub-components within the machine learning process. MLflow is here simply for model management, historical management, versioning, and also it blends in well with MLeap when it comes to the functions that work in unison between the two. MLeap now is basically a runtime. It's a serving tool. It's a serializer. It plays multiple parts in Positron, and it is practically the most important component in terms of our entire Positron tech stack. We will talk about MLeap in further slides. So this is what our pipeline looks like as of today. This is still in development, but about 80% of it is completed. So how we imagined this to be was we thought about this from a configuration-based design. We wanted our Positron configurations to hold all the models and information about these models. Now, when I say information about these models, I mean a certain location that points to a model, hyperparameters or features, etc. So if any data scientist would actually look at one of these configurations, they would understand exactly what is happening in this model and how the model was built and what kind of features are being used. So it's a pretty simple flow in terms of looking at what happens. We get active models. We fetch certain features based on what the configurations entail. We also begin training. We have an MLflow server. This is all still yet to be built, but this is how we envision it. And we have MLflow logging. Now, MLflow logging is going to maintain our historical training sequences, also various KPIs that we wish to track. Could be accuracy, it could be precision, and other KPIs that deal with feedback, etc., that is fed back in the system over the following days. Now, MLflow exports. Now we have this component between that exports the model to an MLeap bundle. This bundle basically is a Spark model is serialized into this ML bundle format, which MLeap is going to use further down in the process to serve. Once the model is saved to GS, we have a model registry where a user can go and look at the various models that have been trained, etc. The MLflow UI has been probably seen by most of you. Once we evaluate the model with simple parameters like looking at accuracy, precision, recall, etc. Then we ask ourselves, okay, do we want to deploy the model by, obviously we may have trained 10 models with different hyperparameters, pick up the best model, deploy it. The next part is, this is not done. This doesn't assure that we have a best model yet. So what we do is we evaluate the model in production. Now, this part includes exposing the model to a certain set of population and seeing how actual KPIs how the needle moves for actual KPIs. If it moves positively for 5% of our population, we start opening the doors. We bring it down to 10%, bring it up to 10%, 15%, and 20%, and further on. Once we're ensured that our model does perform well in a real-time scenario, that's when we decide to move it into production. The ML serve service is the brains of the serving part of it. It basically orchestrates a lot of things to do with different models that are being deployed. Each model is deployed essentially as a new service that talks to this TCML service. So you have TCML talking to various TCML model services, and that's how predictions are basically served. Now, in terms of our online feature store, all our online features are stored in Redis as of now. So we maintain a one-to-one parity. Everything that's in our offline store is also at Redis at some point of time, but Redis may hold newer information compared to the offline feature store at the end of the day. Yeah, we can go to the next slide. Over to you, Bart. Yeah.
Yeah. So we started from some need. So at Truecaller, we had a problem where people upload profile pictures that often had illicit content. There was a dire need to flag these images in a short period of time. Along with this realization, a few other light bulbs were turned on. Essentially, we also had 3 other models that fit into deployment process, but we didn't have any platform to do so. So this led to the birth of our vision. Requirements entailed support for SparkML, like Lini said. Most of our models were trained on SparkML. So we wanted to have possibility to wrap these model services inside our Scala microservices. There were a lack of pre-built choices to meet our requirements until we stumbled upon MLOps, which aligned with our requirements. So yeah, we were happy that it is, and we use it in our project. Our requirements were based on tech stack that our engineers use on daily basis. So models can easily be managed by our backend team with great flexibility. We also proved that our microservices can handle high traffic, and we need it also for our new ML services. We had plenty of processes already in place for development, monitoring, and deployment of our microservices. Hence, we wanted to reuse this battle-proven experience. As mentioned earlier, we didn't want to reinvent the wheel and use pre-built state-of-the-art machine learning models, and at the same time support new migrated models that are created by our data scientists. So building our own platform make it possible to customize our deployment and development processes in a way that it is easy to understand for us. So yeah, thanks to our way of building in parallel, we were trying to create platform and yet deploy our first model to production. We were able to finish this first part of the project in 3 months, just with 2 backend engineers and 1 data scientist. We tried to keep it simple, but still very useful and easy to extend, because we know that in future we will need to deploy more and more ML models. So we believe that in landing on production quickly is top priority. Because due to the fact that validation of your ML model with small chunks of real data, still some edge cases can be missed, and they can only be revealed in production. Our vision for a successful project was to build it at the lowest cost possible, about the best cost benefit trade-off. So we tried to reuse whatever we hand internally and externally, wherever it was possible. For example, we are good at creating microservices, so let's create our own microservices for this. we need to fill the gap between ML models and Scala. It looks like a lot of work, so let's reuse some open source library, MLip. We needed a model that was state of the art for some business requirements. Let's look if there is already created model. And for example, this NSFW model for image classification was already created, and we reuse it, which greatly help to make our deployment faster. And as always, we go with our philosophy of making software that iteratively built, tested, filed, and repeated over and over in this journey to achievable perfection. So few words about MLip. This is basically open source Scala library that allows to serialize models trained in Spark, in scikit-learn or TensorFlow, and save them to file bundles that can be saved in two formats, JSON and protobuf. And it allows to get rid of dependencies from Spark or scikit Python libraries, and allows to load these models inside galaxy of microservices where a lot of them are communicating with each other, and our users demand information from us that on instant. We needed technologies that allowed us to serve predictions at light speed. So from the beginning, we were using gRPC, which is much faster in case of serving as JSON. Also, we saw that using gRPC, our network traffic bills are much lower. Also, to be fast in serving predictions, we had to get rid of these training dependencies, like I said, Spark and Python libraries. And MLip perfectly fits in our ecosystem. Also, we choose technologies that use Breeze because that ensures highly performant mathematical computations, and actually Spark, MLip, and this MLip. Yeah, and of course, to make sure we made the right decision to build our own platform, we benchmark with existing solutions. And to be able to reason about the results correctly, we prepared testing environment as close as possible to production one. So we set up deployment on our Kubernetes with the same configurations. We deployed 10 models of 3 regressors, and that was executed sequentially during prediction. And that regressors were trained using scikit Python. And to run our benchmarks, we use Gatling, which generated requests for our positron and the other deployment done with Saldon. So we sent 10K requests for some period of time and measured the latencies. And yeah, we were very excited when we first saw these results, because it looks like our solution was 10,000 times better than Python one. So yeah, of course, everybody should do own benchmarks, but this gives nice overview how much we can gain from using ML model inside more performant environment like Scala than Python. Yeah, Lini, to you. Maybe you're on mute. I can hear you.
Sorry. Yeah. Thanks a lot for that, Bart. One thing to mention as well, and I think it's a really important facet of MLeap, is that it does not require a Spark context, and that's what makes it incredibly fast compared to compared to Spark MLlib as well directly. It also makes use of leaf frames and not data frames, which is basically a lightweight data frame, which has all your basic data types that are required for machine learning processes. So moving forward, the next part is we're going to be talking about risks and benefits of homemade ML platforms. As you know, everything is not always rosy and shiny when it comes to building these platforms. Today, let's talk about a few things that are good and bad about it. So let's talk about the risk first. Cost of creation may not always be worth the benefits. This is due to the fact that sometimes an MLOps platform is not required if you don't have sufficient use cases. Let's say if you're focusing on one model type and your product only requires that model type, and eventually over time you're going to be focusing on polishing that model, it's unnecessary for you to build an MLOps platform to just support one model. An MLOps platform is generally built to have a wide variety of support use cases, which may arise from different business unit or completely different model building processes. Um, the next part is the open source part, right? Since open source libraries are funded by people all around the world, you have various small communities, large communities alike. Um, what happens here is that custom solutions are not exactly built here and fixed into open source. It's not managed. So at the same time, you're not paying for something that you may probably require, and a lot of custom components may have to be built by yourself. And this also entails learning everything about this open source code. So a lot of time goes into this and resources as well. The next is you need a larger team with new expertise for custom components. I think this goes hand in hand with the open source part. Building an MLOps platform is not that easy because it involves DevOps professionals, it involves machine learning engineers and data scientists as well. Together, you can create an MLOps platform. Um, but this at the same time has a high cost and also takes a lot of time. So these are a few things to consider. Unless there is light at the end of the tunnel, or it's going to be fruitful and aligns with your vision, then it makes sense of putting some effort into this. Platform management becomes a nightmare again. Based on initial design decisions, again, a dedicated set of engineers is required based on company size and complexity of the platform. When it's self-managed, when it's not managed by the company itself, and it's managed by an external third-party provider, it's a lot easier in terms of dealing with bugs or performance tweaks or even upgrading certain things. Here, everything needs to be managed by a certain team secluded that will probably only manage your MLOps platform. So it does have its own cons as well. So let's talk about the benefits. I think a lot of these benefits align with our learnings and what we've done here. So building a custom platform and not depending upon a self-managed platform also reduces the bills. That being said, and of course, like I said, it has its pros and its cons, but it's much cheaper. It's customizable. You're not locked in with anything, so you have that leeway. The ability to customize and fine-tune various components gives us flexibility to tailor the solution to exactly what's required and avoid redundant components. A lot of these platforms come with things that you don't generally need or will use, depending upon where you are in terms of the data maturity life in your company. So creating something that is lightweight and fits right into the empty spaces that you have makes a lot of sense in terms of building your own platform. Again, open source, the biggest advantage is that it's free, right? You have community of engineers, again, debugging and applying various components in their production environments. And at the same time, it's beneficial, but like I said, there's a lot of effort and resources that need to be dedicated to open source technologies. Building on top of an existing system may be a nightmare, right? Especially when multiple migrations are required to enable compatibility and seamless integration. A homemade platform enables us to integrate this support at the nascent stages of development. So exactly at stage one, you know what you need to create in order to integrate with your current services and not create a huge migration flow or task for the rest of the teams to carry out, right? The next is you always, whenever you probably have a managed platform, you notice certain model flavors are locked to that system. They cannot be migrated. And that's the whole benefit of this. We generally, when we decided to create Positron, we also looked at it as where we could adopt external models and internal models that is not locked by some vendor or vendor requirements. And this also gives us the ability tomorrow to create maybe Positron 2.0 that's not based on MLeap, but based on something else, but at the same time, migrate all our models if required, right? And this is a good advantage because today we do support multiple model flavors, and that's exactly what we were aiming to do. So let's talk. This is our last slide, and where do we see a Positron going? More and more models today. Currently, we have 4 models that are deployed. We plan on deploying even more, some with reinforcement learning as well. And this comes to my next point. With Apache Flink in place, we plan on applying reinforcement learning and maybe create predictions in real time as and when users provide us feedback, giving no cooldown period, but at the same time, improving our KPIs by the second rather than improving it by the day. We want to build a common platform for all business units where any BU, any data scientist can go up and say, hey, I have this model ready. I just need to drop it in a certain folder and we're in production from there. We want to make it that simple for all data scientists so that they can focus more on scientific research and solving problems rather than focusing on how will this fit into the whole architecture of deploying your models. Now, custom transformers are something that's important and something that needs to be mentioned is that MLeap does have transformers that are similar to Spark and the same as Spark basically. But if you want to write certain other transformers, the ones that are not in the scope of, for example, you would say string index or one hot encoder, certain other ones, you need to write custom transformers. Now, this also requires good understanding of MLeap and its libraries, but we want to build a big library of custom transformers so as to give us an edge over Spark MLlib, at the same time, replicate exactly what Spark MLlib provides us. We also want to check out different serializers. Besides the ML bundle, there are other model serialized flavors that are there, which are PML, ONNX. This is also coming back to my point where tomorrow, maybe if we leave MLeap, we can also accommodate for other runtimes. But yeah, I guess this comes to the end of our slide, and a saying, to reach the stars, you need courage and vision. Thank you.
Yeah, thank you. Thank you for having us.